Yay, welcome to another lecture in the Sweatbox. Hopefully the aircon will kick in the next 1.5 hours. Thank you for coming during lunchtime as well. So before we start, I've got past sessions started this week for those of you that have joined past sessions, which is the peer-assisted study groups. And so I've got the two group leaders here. They've just come to do a little intro. Did you want to say something about PASS? Yeah.
Is there a mic?
Yeah, you can use this.
Oh, thanks. Hey guys, I'm Daniel, one of the PASS leaders. I'll try to keep it short. PASS, as mentioned, is a peer-assisted study sessions. It's just a place where you can come and discuss the lecture content, pretty much, and we organize some fun exercises for you. This week we have a Kahoot quiz and mind mapping exercise. And yeah, they run every week on Wednesday and Thursday on campus and online. Today we have a session at 5 p.m. on campus and 2 p.m. online as well. That's pretty much it.
Hi everyone, my name is Adrian. I'm the other PASS leader. And personally, I believe that the best way to check your understanding is to try and explain it to your peers. And at PASS, you have the opportunity to do this. So come along. I have a session at 2, which is right after this lecture. So if you have any questions that you don't get answered today or in this lecture, come along. It's a great opportunity to meet some friends as well.
Yeah, thank you. Thank you both so much. Yeah, so just another avenue for you to be able to get together with other people from the course and get some help if you need help, but not about assignments. Sorry, they cannot help you with your assignments. And assignment is coming next week, so close. So you can spend the weekend excited about what's coming. It's so fun. Well, I think it's fun, but I'm obviously biased. Okay, so here we go. Today, an exciting lecture because we are going to start arrays, which is going to be super exciting. Again, so on Monday we talked about good style and how to style your code. We talked about why you want to style your code as well. I hope the main reason really is so that a human can read it. For you in 1511, it's so that we can read it and give you extra marks if something doesn't compile, especially in your assignments as well. And then we also talked about functions, which is another thing that we do to help us have good style to start with, but also to help with reusing code and making sure that we don't just repeat the same code over and over and over again. So it helps us to really make our code more efficient, make it more readable for other humans, and it helps to style our program so much better. And we will go through and rehash functions today as well. I'll run through what it's doing with the last program that we made. Okay, today, hopefully some aircon. That was clearly just some wishful thinking on my behalf. I can't feel anything. Can anyone, out the back, can you feel any aircon? Because, no, okay. You can feel something? I'm going to change to stand over here. That's the spot if you want aircon, apparently. So I've been promised now 5 times that an aircon tech will come out and look at it, but it hasn't happened. So maybe on Monday when it's 38 degrees and I have a thermometer in here. All right, so today we're going to look at arrays. I had also some wishful thinking that we might look at strings, but I don't think there's going to be time. But if there is, maybe we will. But it might be some wishful thinking and we'll do them next week instead so that we're not rushing through things. Okay, live lecture code. Tom's on it. Don't even have to ask. Okay, so for my quick recap of functions, what I thought I would do is I would actually run through the functions that we build in the lecture. I'm putting it in dark mode for this lecture and then I'll switch it back to light mode. There has been a lot of discussion over here. Everyone's like, how do you stand it? Because I code late at night, so I stand it because it's what keeps me awake. Okay, so let's run through this program that we kind of wrote towards the end of the lecture on Monday. Okay, I'm going to go here. Oh, that's what I forgot to do. I forgot to get the pen going. All right, so here we go. Okay, so we start reading our code, we include our standard input-output library, then we go to a constant definition. So we've got a constant definition of target, and it's got a value of 7. We are now telling our compiler that there is 2 functions that might be involved in this piece of code, in this program, and we're telling the compiler that this is going to be the declaration of this function that we're going to use later on. What this allows the compiler to do is it allows it to check that everything is being called correctly, and it doesn't make a call out if we have somehow stuffed up. So what it's telling it is this function is going to return an int. That means it's going to return a number, an integer value. The function name is going to be sum_dice. And what this function is going to get is it's going to get 2 things. It's going to get 2 ints. The first int is going to be a variable called number1, which we don't really care as much about what the name of the variable is, but it's going to be an int. That's the important thing. And the second one is also going to be an int. And then the second function is also going to return an int. So it's going to use that keyword return in it. And then it's going to be called compare, and it's going to get an int as its input as well. So when you call the function, you know what you need to give it and to make that call out to it. Okay, then we enter our first function in here. So we enter this function int main void. That is always the entry point into a program in C, and then we start reading in order. All right, first things first, on line 26, we create an int, and the name of it is die1. So we've got one variable, we've declared it, we haven't initialized it to any value, it's just declared. On line 27, we create another variable, and it's int die2. Again, we've just declared it, it's not initialized with anything yet. Then on line 29, we create another variable, we've declared a variable int flag. So another int called flag, and this time we're going to initialize it as well and assign it a value of 1. So we've given it a value of 1 to get started. Okay, then we go to line 31 and we go inside our while loop. Inside the while loop, we check the condition of the while loop, and it's calling this variable flag, and it's checking is 1 equals to 1. Yes, it is. So because it is equal, I'm going to head into the loop and do something exciting. I'm now going to have to scroll down, which means some of those will not line up, but absolutely not line up. So I'm just going to erase them to start with. Okay, so I'm going to print out a statement onto my terminal. So it's going to give me a statement on the terminal. Then I'm going to use a scanf. We've got a little note here, remember to error check, because we haven't done any error checking, that scanf has returned something, or it's scanned in a number. And it's going to scan in a %d into the variable die1. Okay, so let's say, I'm just going to say, for example, we're going to put the number 3 in, and that means that at this point in time, into die1, the address of this one, a 3 will be put into. So it'll be assigned, initialized with the value 3. Same thing, I'm going to go to line 34, I'm going to print out what is die2, and then on line 35, I'm going to scan that value, and let's say, for example, we're going to scan in value 5, and it's going to put it inside die2. So it's going to assign the value 5 into here. Okay, also might want to do some error checking that the die values are between 1 and 5 at some point. 1 and 6, unless you're using some sort of magic die. Okay, and then you get to line 40, and you go to the right side first, and what's happening here is a call is being made to a function. So to call out to a function, what you do is you call it by name, just like you would call your friend by name if you were calling out to them. So you call it by name, and you tell it, what am I going to give it? You know, what are the inputs that are going into it? So notice when you call a function, you do not have to say, I'm giving you an int die1 and an int die2, because that was already, you declared that you're going to give it to ints. So now it's assuming that you are going to give it to ints. So you just have to put in 2 variables that are ints into that call function. Okay, so now that the function has been called, I need to go to that function. So I'm going to move the screen down to the function, and it's going to go in here. Okay, so the call has been made. And once this call has been made, it's going to go down to the function and it's going to do what's inside the function. So I've given it 2 ints. That's excellent. That was in the definition, which means that everything's okay. It's going to make the call and it's going to head into the function. Again, it's going to return from here and we want to return an int. It's going to return number 1 plus number 2. For these 2 values, it's using what you have specified in here. Because when I put in die1, what happens is a copy of die1 is made into here, and a copy of die2 is made into here. So now the values are that number 1 has the value 3 in it, and number 2 has the value 5 in it. So what you're returning is a maths 3 plus 5. That means after you finish this function, so when you get to the end of the curly bracket, you're going to go from here right back to where you called from. So you called from line 40, you will return to the line after you called, and you're going to take that return, which is 8, and the 8 is going to be assigned into this variable here. You've said you're returning an int, and that means you have to assign the return value to an int as well, because they have to match the types. Okay, so now sum, I've got an int sum that was declared, and it's got the number 8 in it. I will now move to line 43. And what I'll do here is I'll say, okay, flag is equal to compare sum. I'll go to the right side of this and I will, looks like, make another call to a function called compare sum. So I will move to here and that's not what I wanted. Oh, okay. Okay, it's I've never seen this happen before. There we go, it's back. It was just moving my... Okay, so now we've gone into here. So we have sent it off with some facts, and now we're going to see what it's doing. Okay, so when we called compare, we gave it the value sum, and sum is equal to 8, so we called it with the value 8. So basically what we've done is we've called compare with the value 8, and that means when we go to do this function, what's happening is that it has assigned a copy of this into here. So now that it's assigned a copy of that in here, it's going to run through the function. So it's going to go in here, and on line 67, it says int flag is equal to 1. So it's really important to understand that is not the same flag that we have up here. This is a flag from our main function. Okay, this is not the same flag that's now in compare function. So let's say our compare function is now running here, and what happens is it's got an int flag, and this flag is equal to 1 as well, but it's not the same flag, it's a different variable. I'm going to go to line 68, and I'm going to say if sum is greater than target. Sum right now is this int sum here, which is also the one used in here. It's a copy of it. So I'm going to check that 8 is greater than target. Target was 7. Is 8 greater than 7? Yes, it is. So that means I'm going to go into this if statement, print out the sum is greater than the target number. Then I'll move to line 70 and use my keyword return flag. I'm returning this flag over here, and as soon as this keyword is encountered, what's going to happen is that value is going to be returned back to where it got called from. So it got called from here, and that means this function here has now returned 1, and that's going to be assigned to this flag. So that's going to get a 1 in there, and then it's going to move out to return 0, and it's going to finish. When you come out of that function, you're going to kind of get rid of this. This is going to move off the stack and free up that memory. And when you come out here, all of this is going to go as well and free up the memory again. Okay, how is that feeling? Running through it line by line. Is that... What? Yeah, Paul, thank you. I was like, I don't know if you're saying it feels good, but I'm like, well... Okay, so someone on the chat is saying, I don't get the flag is equal to compare sum. Okay, so what's happened in here is I've called a function, and I've assigned the return of that function that I've called into the value of flag. I don't know, sometimes it feels like nothing works in this theater. Okay, so what I've done here is this variable here, int flag, what I've done is I want to reassign a value to it. So what I've done is I've called the compare sum. Sum was equal to 8 in this case, which means that I've called the function called compare, and that means I've called this function here, so I've moved here after the call is made, and what I'm going to do is I'm going to actually run this function with an input of 8. So I'm going to go through this function. When I run it, it's going to return some things for me, and then when it gets to a keyword return, it will return whatever value this different flag has. So it is a different variable to the one that was in the main, and it's going to return it back to where it was called from. So it's going to come back and it's going to return, this function returned 1, so it's going to return a value of 1 and assign it to this flag in here. So that's what happened on that line. Would the code still work without line 69? What is line? The printf line? Or do you mean the 70 line? I think you mean 70. Okay, so if I didn't have this return flag line, for example, what would happen is this. Let's say I didn't have it. I've sent it in with an 8. What will happen is it will check, is 8 greater than 7? Yes, it is. It's going to print that out. It's going to come out here. It's not going to do else if, and then it's just going to go to here with no return. So you're right. Right now, line 67 for me. Now I've got a different. Okay, line 67. Right now, it doesn't have a purpose in particular, but it might have a purpose further on. But yes, you're right. In this case, it doesn't actually have a purpose because over here, if I just switch back instead of making red dots everywhere, what happens over, oh no, it does have a purpose. I'm sorry, I didn't see. The purpose is if it allows me to keep guessing. If I'm going to return a 0 in here, then it's going to stop me. It means I've hit the target. Okay, how is 109 votes? That gives a pretty good. Okay, so there is a point to line 67, but it could be done a little bit neater potentially. This is not the neatest way to write this piece of code at all. Okay, how's everyone feeling? Not happy with just a few of those online comments. Okay, so if you have no idea what's going on, please feel free to ask in the chat as well, or put in the chat what is exactly not making sense to you. Where have you lost it? Also, we're going to be running revision classes next week, and I'll put a link to register for that up. So if you have no idea what's going on, please come along to the revision class so that you can catch up, and also ask in your tutorials and labs. Yeah, okay. So someone's asking the flagging business. Okay, so the flagging business is really, it's for the loop, and it's to keep me going, so it's going to keep me guessing until I hit the target number. And so basically what I'm doing with that flag is if it's 1, keep guessing, and then if it gets to 0, then you've guessed already, so I don't need to keep guessing, so stop guessing. So when I hit the target in this compare one, so you have the target number, it's going to return 0, which means that this loop will no longer activate because I'm not going to need to. So the flag is basically a true or false. Should I keep looping or should I stop? And then I branch depending on what I want to be doing. The flag is not a specific command, it's a variable. Okay, so someone's asked, why do we need line 67 and not just return 1? Okay, that's a very nice question. And very good question. The reason I'm not just returning 1 is for code readability. Okay, if I return 1, what it implies in the way that we write code is that something has gone wrong. The program has exited with errors, basically. So it's implying if you're looking at it kind of just looking at some code, and I'm looking at your code and I see a return 1, that's what return 1 is saying to me if I'm not kind of reading it in depth. So I'm using it for readability as well. Okay, I think that's all the potential questions. Yes, someone, yes. So each function only has access to the constants, not the arguments of the, so each function only has, a variable lives between curly brackets. So if I have this here, for example, and I suddenly decide, okay, I'm going to have an int a in here, and I'm going to go, okay, a is equal to 5 here, and then here, maybe I'll say, okay, printf something, and I want to printf the a. I will not be able to. There is no value to that a anymore. So if I try and do that, and I'll just demonstrate it and run it. So let's say I want to do this a. So let's say this is just an example. There is no point to this piece of code right now. So I'll do dcc functions.co functions. If I do that now and save the file to demonstrate what it is that I mean. Okay, someone also on the feedback asked me to use shortcuts to do my saving and stuff. The reason I haven't been is it's because it slows me down when I don't use shortcuts, which is why I haven't been using shortcuts. Okay, so this is what I meant. So it's going to say error, use of undeclared identifier a in here. And that's because inside these curly brackets is the only life that a has. Okay, a is going to be wiped from memory at the end of this curly bracket. Okay, so be careful where you kind of initialize your variables and where they're available to, that you're not returning things that don't exist. Okay. We'll just get rid of that because that's not really necessary. All right. There we go. Hope that was better. Okay, let's do it. Let's do arrays. How exciting! Nope, not here yet. Okay, let's do arrays. That is one of the basic data structures that you're going to learn in this course. The other one will be linked lists after the break. Which is, I don't know, there's always internal battle. What's better? What's better? What do you like better? Linked lists. Tom? Linked lists. Oh, what is this? Tammy? Oh, okay. So everyone seems to like linked lists more. I don't know. You can draw a lot more in linked lists. Arrays are, I mean, they both have their benefits and they both have their downfalls. But an array is a pretty important data type. It's a very basic one. It's an important one to understand in computing. How many people have used arrays before in other programming? Yep, quite a few. Yep, okay, sounds good. Okay, so an array is a collection of objects, okay? Basically, it's a collection of objects, but all of those objects have to be exactly the same type. You can't have an array that's got ints in it and doubles in it and char in it and something else in it. It all has to be the same type. So if you've got an array of ints, every single thing in that array is going to be an int. And if you've got an array of char, every single element of that array is going to be a char. You can't have something else in it. So this is kind of different to the way we do a struct, where we can combine different elements and different data types together in one. And what we can do is we can actually have an array of structs. We can have an array of anything, really. But we can have an array of structs as well, which we will play around with after we do some basic arrays as well. So the one wonderful thing about arrays is that they are indexed, which means that I can access things very easily. And I can manipulate things very easily in them because I just need to use the index of whichever element of an array that I want to access and manipulate. Okay, so if I have an array, nope. Okay, this is what it looks like, for example. Let's say I want an array that has that will hold 7 things in it. And let's say it's an array of int, just because ints are the easiest example because they're fast to do. And when you have anyway, array of chars we'll leave that. So let's say I have an array that holds 7 integers. You might have heard it often kind of said, computing people always start counting at 0 just to make things more fun. And we do. So arrays are indexed at 0. They start indexing at 0, which means that if you want an array that holds 7 objects, the last object in that array is not going to be at index 7. It's going to be at index 6. So you're always going to be 1 down from it. Now you might think, okay, well that's okay, that's clear. This is one of the most commonly made mistakes when you first start programming, is that you keep trying to access an array that doesn't exist. So that is one thing to watch out for. And the way we go through the array is that I can't just be like, hey, printf array, and then it will do it for me. It will not do that for me. You have to access every single individual element of the collection, so of this array, to be able to actually print out an array or do anything with an array if you want to kind of do anything that will, that will involve moving into the whole array, or putting things into the array, printing things out of the array, manipulating each element of the array. You can only do it one thing at a time, because it doesn't make sense if I say, okay, manipulate this array, make it 5. You don't know what to do with that. Where should that 5 go? There's quite a few things that you can change in this array. All right, let's do an example. Should we do an example? Let's do an example in code. Okay. Let's do it. Actually, this is a good place to bring out a for loop as well. We haven't done them till now. We've just done while loops. Arrays are super, they love fors. Yeah.
Can we have a for loop go through like arrays in the Python?
Yeah, and we're going to use, I prefer using a for loop in an array because then you don't create madness as much. But while loops are so much nicer in linked lists. So, you gotta really play around with what's better. Okay, so let's do a little program. We'll draw it out. We'll see what it looks like. We'll see what it feels like. Hopefully, you will love arrays as well. Let's say I want an array with the values 1, 3, 4, 5, 9, 10, and 11. And then I would like to calculate the product of these numbers. Okay, so really, right now, without arrays, you would have to do that by doing int a is equal to 1, int b is equal to 3, int c is equal to 4, and so on and so forth, which, is great, but is quite tedious. And also, this is just 7 items, which is not that many. What happens if you've got 100 items, 200 items? It's going to get old very, very fast. You've then got a lot of variables that you're keeping track of that are moving onto your stack. What do you do with them? When do you kill them? Where are they available? Where have you reassigned them? So this is one of the point of arrays, is it combines these kinds of collections together, but they just have to be of the same data type. And that means I don't have to do something like that. I can just have an array that will house them. Okay, so the syntax for doing an array is, because I said an array holds a collection of things and they're all of the same type, you've already kind of seen it. We always say what type we want. So again, we need to tell the compiler what type we're looking for. Now I've got ints, so I want an int array, and I'm going to call it array. Okay. So far so good. I've set a data type. I've given a name to that variable, so array. And now I need to tell it that I want it to be an array, not just a variable. So if it was a normal variable, I'd finish it there. Jolly good. But if it's not, then I want to say it's an array. So to do an array, I will say, I will finish it with square brackets, open and close. And that says, create an array for me. Okay. So right now, I haven't said how big I want that array to be, which is not what we encourage you to do. What we encourage you to do is to be able to say inside these square brackets how big the array is going to be. Now, in here, I've hash defined a max array 7, so I'm creating a very, very small array, but I'm going to put it inside the square brackets. And what this will do is it's going to create a variable that kind of looks like this, when it reads this, it's going to create a variable that 1, 2, 3, 4, 5, 6, 7, and the indexing is going to be 0, 1, 2, 3, 4, 5, 6, and it's going to be called array. Okay, now each one of these is going to be an int as well. So it's kind of telling you, okay, this makes sense because what that means is now as a compiler, I know how much memory this array needs in memory. There is going to be 7 ints that are going to make up this array. So I'm going to really need, 7 times 4, 28 bytes to hold this array. Okay, so I can do a few things. I can't do this though in syntax. I can't then be like, okay, array is equal to, I don't know, 1. Done. Can't do that, okay? Can't do any of that. So I've got one option. I can initialize an array straight away on the same line that I declare it. It has to be in one foul swoop. It's not really very flexible, but sometimes we do it, and sometimes we don't do it. If you want to initialize an array, you will put it inside little curly brackets, and then you will put some values in there. So 1, 3, 4, 5, 9, 10, and 11. So what that will do is that will actually initialize the array to those values. You won't actually do that this initialization that often. You will usually have to read something into your array. So now what this line of code does is it places these values into the array. So 10 and 11. So it's got an array that it's initialized as well. But most often than not, you will, and we will do that next. We'll scan through and we'll read things into the array. Okay, so let's do something very simple. Let's just first go through the array and print out what the values are in that array. Yeah.
If we don't initialize the values in the array, if we just say int array and then size max array, is it just going to be int? Is it going to be int 0, or what's the value inside the array?
So you could also do, something like this. I'm going to put it as a comment so it doesn't. Okay, if I do that, that will give everything a value of 0 in there. But sometimes that's not, sometimes, okay, and this is one of the drawbacks of arrays, okay? I have to guess how big I want my array to be, okay? So often I will say, all right, 1024, just for fun, and I'll create an array that's got 1024 elements in it, indexes, and I'll only use 3 things of it. Okay, so it becomes a waste of memory as well. So it's one of the, but everything might be filled with 0, or it will be nothing. There'll be nothing there. I can't, after I have created the array, I can't add to the array, and I can't take away from the array. Okay, it is built at compile time. There is a way to do dynamic arrays, but it's absolute havoc, right? We might look at it briefly, kind of not as a testing, but just as a fun thing. But it's madness, right? So when you want to be doing that, that's when you're going to be looking at linked lists as opposed to arrays. So arrays are very set in stone after you run that. Okay, so now we've got an array. Let's traverse through it and let's just traverse through it and print it first, and then we're going to see if we can do other things with it. So let's traverse through the array. Okay, so let's go through it. How do you think we go through an array if we have this structure and each index is numbered consecutively? What do you reckon? Yeah, we loop through it. Well done. So we loop through the array and we access every single element in it. Okay, so far we've only done while loops. So what I'm going to do is I'm going to use a for loop this time, okay, for funsies. So let's do that. Okay, this is the syntax of a for loop. Basically, a for loop operates the same way as a while loop, and it kind of takes the syntax, you put a for in, And then you have 3 things inside your for loop. And it's the same, you know, when we talk about a while loop, we have a loop control variable, we have a condition that we're testing for, and then we update the loop control. All of that is now going into one set of brackets, into the 4 brackets. So the first thing I'm going to do is int I is equal to 0. Now, you will be like, oh my gosh, she's using I. That's wild. She's told us for the last 3 weeks, do not use single letters for variables. This is the place where it is acceptable to use I. It usually stands perhaps for index, but this is an acceptable place in terms of style. It's obvious when you're looping through and indexing an array what you're doing with those i's. You don't have to use a variable called index or anything like that. So for I is equal to 0, and then my condition will be what? What do you think will be my condition for the loop? Yeah? Yeah, so we want I is less than 7. So we don't want to go past the end of the array. Sophia, you're really not hitting anyone in the head today. You're not even disappointing.
I'm sorry, Sasha, I'm sorry.
Okay, so I could say I is less than 7, or I can use my hash define, and I could say I is less than max array. Now, am I going to have I less than or equal to, and equal to? Less than, excellent, because if I have equal to, I'm going to travel past the end of the array, because an array finishes at the end.
I'm going to knock someone out.
Was that bad language?
Sorry, Sasha.
Okay, so we've got, and then we're going to say, what is it that how are we updating our index? And I'm going to, excellent, I++, well done. Okay, so remember that's saying I++ is the same as saying I is equal to I+1. I'm just adding 1 to it. So I'm moving through it. Okay, so that is a glorious for loop. And then inside I'm just going to print out, let's do %d and a new line. And then in terms of what am I printing out? I am printing out what is inside my array, and I'm printing out what is inside index I, okay? So when I is equal to 0, it's going to print out, in reference, it's going to print out what is sitting inside array, the name array, at index I, so at index 0. So it's going to print out a 1. Then when it moves by 1, it's going to print out what's sitting at index 1. So it's going to print out a 3, and so on and so forth. So let's try running it now and see what it does for us. So let's do save. Okay, what have I done? Prepared it for the next question, sorry for it. Can you see the font, by the way, out the back? Is that all right? The font, is it big enough? Yeah, we'll just go with, yep. Okay, and let's run it. And so now it's going to print out what's sitting inside the array. So it's going to print out, and the array had 1, 3, 4, 5, 9, 10, 11, and that's exactly what it's printed out. So it's moved through the array, and it's printed out all the elements of the array. Okay, how are we feeling about a basic array and moving through it? Yep, Tom's on it. I was like a shower of hands. No one's doing hands. I feel like I feel air conditioning as well, a little bit.
Yeah. It's like cool down until the body heat from coming in. It's regulating again.
Yeah.
So like how the values that the array
We can change them if we want. We can absolutely manipulate whatever we want. I could just be like, what would you like to change?
to change like change 11 to like a character.
Okay. I can't change it to a character because everything has to be an int. So I could change it, okay, to a... Not in this case. It will treat it as a character because it's going to be A, B, C, and that's how it, because it's going to be in quotes, so it won't. I see what you're saying. It will. with arrays. Yeah. So you can do funky things, but yes. Yeah. So let's say we change the last element to 40. I want to change array at index, and if I know I want to change the last one, I could even have in here max array -1, because that will give me 7 minus 1, which is 6, and I can assign a new value to it. And then let's say I'm going to print it out again. Okay, so now I'm going to print out it again. So let's save it, and let's see what it does, and then we'll talk about what's going on there. So let's run it. And so the second time it prints it, so it's gone to 11, and then the second time it's changed it to 40. Now, if we have this situation here where I've done something, I've done a for loop, I've then changed something, and then I've done exactly the same for loop again, what is this a good contender for when I've repeated code? Yeah, functions, okay? So this is a very good contender for functions, because I've just repeated a part of code, and what am I going to do? Every time I modify a piece of the array, I'm going to just, use the same piece of code and call it again. So let's write a function for this, for printing an array. Okay, what should we call the function? And this is going to give you arrays are wild. Let's call it print array, and I'm going to give it array to print out. Okay, so let's have this function. Now, if I call out to this function, print array, can you tell me what would be the return of this function? What would be the output of a function that prints out an array? This is a very good question. I'm about to answer it. Yeah, it was asking how to, yeah, very good question. Okay, what do you think will be the output of this function that's printing out the array? Int? You reckon? If I'm printing, will I need to return anything? It's a very good guess. Or am I printing already out to terminal, so I don't actually need to return anything from this function? Yeah. So usually anytime I have a function that just prints, it's going to be a void function because I don't need to return anything. I just print out and then I move on with my life. Okay? So my output is going to be void because I'm not returning anything. Hey, can we settle down a little bit? Settle down. I know arrays are super exciting. Everyone is just pumped for arrays. Okay, and then what will be the input? The input will be my array. Okay, now that means my function is void. It's called print array, and I'm going to give it an array. So I'm going to give it an int array, and that array is going to have a size to it. Okay. All right, and now what I'm going to do is I'm going to take this piece of code and I'm going to move it in here. How is this now slowing down? This is just not feasible.
No, mine is slowing down too.
Okay, so that should do it. Okay, and now let's delete this, and we'll call the function from here as well. Okay, so you can see when I'm calling this function, I'm just saying print array, and then I'm just saying array, which is just wild because it kind of like feels like it's not doing the right thing. I'm just calling a whole array, even though I told you it's not really possible to like have the whole array at once. And I need to go through it element by element. But here I am calling a function with an array name and hoping for the best. So we will look at it more in week 5 when we do pointers. But basically what an array is something called a decaying pointer. And that means that what is being passed is when you pass this function, when you make this call out to the function, What's being passed is the 0th index of the array, the address of it. Okay? And so when you pass the 0th index, because I've told it I know how big this array is, it knows exactly where it's located in memory, because arrays in memory are given consecutive locations. So that means in your memory you're going to have every 4 bytes is going to have, so something like this, it'll start over here, that's going to be the address of it. This one's going to be 4 bytes later, this one's going to be 4 bytes after that. So it's going to be consecutive, which means that I know where to find every single element as long as I know, where the start of it is and how big it is. And that's why we just make a call out to the function. It will become more clear in week 5 as we do pointers as well with memory addresses and how it works in memory. All right, so let's try running it. Okay, I've forgotten to do something. What have I forgotten to do? I've forgotten to tell C that this function is coming, so I've forgotten to prototype. So I'll just pop that in there, save it again. Let's try it again. Okay, so now we're running, and let's try running it, and now it's running, and it's also using a function, which is quite nice. Okay, great. So now I've gotten it to print out an array. We've kind of talked about modifying the array, which is nice. And we will do more practice, don't worry. And your whole assignment 1 is all about arrays, so a lot to look forward to. Let's now go through the array and print out and do the product of the elements in the array. My gosh, am I actually going to be running VLab now? I just can't find a happy medium here. Whatever I use is what breaks. Okay, I'm going to just comment things out so you can try the different things again yourself by uncommenting. So let's now do this where it says traverse through the array and multiply the numbers together. Okay, what do we think we need to do here? We need to move through the array again. As soon as we see that we need to move through the array, that's when we know we need to loop through again and access every single index of that array. So if we do 4, and again we'll do our int I is equal to 0, and then I'm going to go until whilst it's less than max array, so I'm going to go until the array keeps going, and I'm going to increase by 1 each time my index. Now what I want to do is I want to traverse through it and multiply the numbers together. So that means I need to store the result somewhere. So in the top bit, I'm going to have a variable called int product. And what I'm going to do is I'm now going to add things into that product. So product is equal to product, and something's not going to work, and you can tell me what in a second, array I. So what I've done is I have said, okay, could you please take what the product was and multiply it by the ith index, so wherever I am sitting in that array. And I'll run through it line by line as well, don't worry. Okay, what's going to be missing? What's going to be the complaint that the compiler will give me? Yeah. Yeah, it's going to give me an uninitialized variable because when it tries to access product for the very first time over here, it's going to have absolutely no value in it, which is going to be a problem. Okay, this code is going to be very easy to break. I'm going to give it a value of 1 to start with. And then let's print out the output of that. Oh, come on. Nope. There we go. Okay, so let's print that out, and I've called it product, so let's save that and print it out now. Okay, so compile's okay, and now let's run it. And it's going to say the product of the numbers is 59,400. I haven't done that in my head, so I'm just gonna trust it that it's correct. Okay, so what we're gonna do is let's have a little break now, and then what we'll do when we'll come back is we'll go through it line by line, and then we'll do a harder problem where we'll also scan into the array. So let's have a little break now to get us going through. join and you're not the top 3.
Then you get chocolate if you win. Top 3 gets chocolates these days. Wow. You're being generous. Have one. If you're lying about it, show it.
All right.
I have a free one as well. I've bought some.
What's this? Your voice is a bit louder. What were you saying? Why are you keeping it hush hush? Go on, tell me. I'm watching you. I did tell her off for swearing, even though no one has heard. I mean, these two have heard me, so. All right, let's do it. That's the wrong mouse.
So much better than Cameroon. This is the music. The music. I would say better. Comparable, like, okay, maybe better, but who feels too much attention and I get too much.
Oh gosh. Okay. All right. That's hurting my feelings. Oh. Okay, we'll go through it again. Don't worry. What? It is, but I don't care.
Raise your grievance.
pretty good. Making sure you don't come in the top 3. Okay, all right. Okay, all right. And we need to go through some of these.
Is it like half?
All right, last one. Oh no. No, it's no. Oh, I've made a mistake in the answer. I can see because I remember what I wanted to do. So yeah, that was meant to be something else. It was the wrong piece of code there. Apologies, everyone. Oh well, there we go. Shouldn't do things late at night.
That you, Ben?
Are you in the room? Hey? Alright, awesome. There we go. Someone in the room. What about Ronald? Is Ronald in the room? Who's in the room? I feel like we need to do functions again. Yeah, I feel like we should, yeah, I think we need to do a bit of functions again. So I will... Yeah, they're trolling you, especially when I put the wrong answer down. When I...
Read your mind.
I'm just checking, people are paying attention. Okay. Let's run through this piece of code that we've just done with arrays. and then we will do a bit more of arrays. Okay, I'll start from the beginning, and then I'll just scroll down. Okay, so let's have a look. Arrays, beautiful arrays. Okay, so the first thing, and you'll see this a lot there, hash define max array 7, which means that if you declare an array and you give it a maximum size of max array, it's going to have a maximum size of 7. Okay, then we're telling here that we are going to have a function. The function is going to be called print array. It's not going to return anything, and it's going to take in an array of size max array as its input. Line 14, we enter. We finally start doing some actual program running, and we go down. Line 18, int product is equal to 1, so we're declaring and initializing a variable. The variable is called product, and its value is equal to 1. Then we move to line 21, and we're now declaring, and there is no easy way to do this. Well, there is. I'm going to do it. I should have done it the other way now, because now this is going to get ugly. Okay. I'm going to go horizontal now. Sorry, otherwise I'm going to run out of space. Okay, so this is my int product. And it's equal to 1. Okay, and now I've got an int array, max array, which means that I've made this array and it's got a size of 7. So now I've got array, and what it looks like is like this. 1, 2, 3, 4, 5, 6, 7. Remember, indexing starts at 0. So the indexes with which you access things is 0, 1, 2, 3, 4, 5, 6. So to access the first element of the array, you would actually use array at 0 index to get this first element. So I've got array 0, array 1, array 2, array 3, I'm going to run out of space, and so on and so forth until array 7. And what's going to happen is here I've initialized the array. I haven't scanned anything into it. I've just initialized it myself with the values 1, 3, 4, 5, 9, 10, and 11, which means that here in the initial values 1, 3, 4, 5, and so on and so forth. Great. Then I'm going to go here on line 25, and I'm going to call a function. Okay, so I'm calling out to function print array, and I'm giving it array as an input. Okay, so what it's going to do is it's going to head down to the function print array with holding that array that we have. Okay, so it's headed down here, it's got into here, it's got a print array, it's come down here, and that means it's got access to this whole array. It goes to line 49 and it starts saying, okay, for int I is equal to 0. So now in this print array function over here, I've just declared that I've got a variable. That variable is int I, and its value is 0 to start with. Okay, I'm going to check my condition. So is 0 less than 7? Yes, it is. Okay, I'm going to run through the loop. So I'm going to print out %d array at index I. My index is 0 right now. That means I want to print out whatever is sitting inside array 0. What's sitting inside here? 1. So I'm going to print out this 1 over here, and then I'm going to increase my I. So then my I is going to increase by 1. It's going to become 1, and I'm going to go again. Is 1 less than 7? Yes, it is. So I'm going to go back in here, print out the next thing. So I'm going to print out whatever is sitting inside array 1, because my index is now equal to 1. So that means I'm going to print out 3. This 3 gets printed out. I'm going to increase my index by 1. And then I'm going to check again, is 2 less than 7? Yes, it is. So I'm going to go back. I'm going to print out the next index. So at index 2, what's sitting at index 2? 4. So I'm going to print out the 4 now. And I'm going to increase by 1. And then I'm going to check again, is 3 less than 7? Yes, it is. So I'm going to print out something that's sitting in index 3. What's sitting at index 3? It's a 5. So I'm going to print out a 5. And then I'm going to increase by 1. So now it's 4. And then I'm going to check again. Is 4 less than 7? Yes, it is. So I'm going to print out what's sitting at array 4, which is my 9. So I've printed that out. Then I increase by 1, so I do my I++. That gives me a 5. And I'm going to print out what's sitting at array at 5th index. And that's going to give me the 10 printout. Great, then I increase it by 1. I do my I++. I'm now at I is equal to 6. So I'm going to check, is 6 less than 7? Yes, it is. So I'm going to go and use printf. So printf, whatever's sitting at array at index 6, and that's going to be my 11. I'm going to print out the 11, increase the index by 1, so I++. That means it's now equal to 7. And I'm going to check, is 7 less than 7? No, it's not. So I'm going to exit out of this for loop. Here, the function has ended, which means that after I finish this function, I'm going back to where it got called from. So I'm going to go back to here, return. I've called this function. It's done its job now. Fantastic. So now I'm going to head in here, and I'm going to do this next for loop. So my next for loop, again, it's now got an I here, so it's inside the main function. This is now, no, that's still good. So I now have an int I in here, and that int I is equal to 0. And I'm going to check again, is 0 less than 7? Yes, it is. Going to go in here and do product is equal to product times array at index 0. So product is currently equal to 1, and array at index 0 is equal to 1 as well. That means that that gets calculated as 1 and assigned into product. So that's now 1. I'm going to go and increase my index by 1, so I++. That means the index is now 1. And I'm going to check, is 1 less than 7? Yes, it is. So I'm going to do whatever is in here. And that means my product, which is 1, multiplied by array at index 1. At index 1, it's a 3. So I'm going to do 1 times 3, which is 3, and assign it back to my product. Great. I'm going to increase the index by 1. And I'm going to check again, is 2 less than 7? Yes, it is. So I'm going to do this again. So now my product is 3, which means I'm going to do 3 times whatever is sitting at array index 2, which is my current I. And what's sitting in there is a 4. So 3 times 4 is 12. And that now gets assigned to product. I then increase my I by 1. It becomes 3. And I check, is 3 less than 7? Yes, it is. So I'm going to go back in and do this again. Product is 12. Array at index 3 is going to give me a 5. So now it's 12 times 5. So 60, and that gets assigned into product. And I do I++ to increase it by 1. And then I check, is 4 less than 7? Yes, it is. So I'm going to go back in here and do it again. So now my product is 60. My array at index 4 is going to be 9. So now I'll do 60 times 9, 540. So that's what gets assigned in here. And I increase my I by 1. So it becomes 5. And I'll check, is 5 less than 7? Yes, it is. So I'm going to go back in here, and I'm now going to do 540. And this is where you'll start to see me struggle. Oh, no, it's a 10. How convenient. OK, array at index 5 is 10. So 5,400 now. So I'll assign that into product. So that's now going to be 5,400. And increase I by 1 to 6. Check again, is 6 less than 7? Yes, it is. So I'll go in here and I'll do the final, multiplication. So 5,400 times whatever is sitting inside array at index 6, which is 11. So the result of that is 59,400. So I'll assign that into product. Excellent. I'll increase my I by 1. I'll check, is 7 less than 7? No, it's not. So that means I'll exit out of here. Excellent. I'll go down to line 39 and I'll print out this statement. And I'll placeholder this product in there. So 59,400, which is exactly what it did on your terminal. And then I'll return 0 and exit out of it, which will, disappear all of my things that I had and wasted all that memory on doing the most useless program ever. Okay, how is that feeling? Is that feeling a bit better? Tom, sorry, Paul, thank you. Okay, so Tom's just going to poll if that made sense once we ran through it line by line. And then the next thing we'll do is, why not we make it a little bit more flexible and we'll run through it. We'll scan stuff in. Okay, I'm also going to decrease the size of my array so that I'm not counting up to 7 each time, because that's getting a bit probably boring for you. Okay, someone's asked in the chat, where do we assign the numbers into the array? In this particular question, we did it on line 21, where we initialized the array with certain numbers, initial values already. Okay. All right, let's do this program, and then we'll work from here, because then we'll learn how to scan in as well. All right. Okay, for anyone that knows me well, I have a very bad habit. Well, there's a few bad habits, obviously, but a bad habit of watching very, very trashy television. You know what? That's where I draw the line. The last 2 years, that's where I draw the line. No, I'm not going to. Netflix has been a haven of bad television reality TV shows, which have been terrible, but just can't stop. Actually, Tom Killingback has a similar habit. I'm not going to be shamed on my own. Yeah, that's okay. I'm proud of it. That's okay. Okay, so let's...
Change your meet the team.
That's right. Okay, so I want to be able to track the number of hours I watch trash TV in my spare time in any given week. Oh God, I've gone with 7 days again. This is a disaster. All right, you're going to have to sit through a 7 loop again. I'm sorry. Let's do the working week so we can do 5, okay? Let's do a work week as opposed to a... So let's do 5 days as a hash defined, so it's faster. Okay, so what I'm going to do now is I'm going to have to input how many hours of trash I've watched in any given day. And yep, let's do that. So we're going to do scanning in as well. Okay, so I really want to have an array to keep track of all of this. Otherwise, I need 5 variables to scan in each time, and that's not really a good way to run your program. It's not very flexible either. So let's do, instead of doing 5 separate variables, we will use this wonderful structure called an array that will allow us to track it. Okay, we'll stick with ints for now, but we could make it doubles for fun. Okay, int, let's call it hours of TV, okay? And I want it to be an array, so I'm going to give it a size as well. So remember, I've got the type of array it's going to be, which means what types is it going to store. It's going to store ints, the names of the array, and then square brackets to say I want an array. And then inside it is going to be my maximum size, which is going to be, in this case, 5. So what that means, if I declare something like that, what's going to be created for me is an array that has that can house 5 elements. So when I declare that, what's going to appear is 3. Let's pretend they're all the same size. Indexing 0, 1, 2, 3, 4. And it's going to be called hours TV. And each one of these things has to be an int in the array. Okay, great. Let's do that. Yeah.
Isn't it technically violating the style guide because of your comments?
My comments are terrible right now, and that's because I'm going to show you how to split a printf statement. There is a purpose to it. I made a specifically horrific one in here. Okay, yeah, so someone has noticed that I have terrible printf statements that go way longer than what I should, and I did that on purpose so that we can split it and learn how to split a printf statement as well over multiple lines if you've got long printf statement, because it's a question that gets asked a lot. Okay, so now what I want to be doing is I want to be scanning into an array to see how many hours each day. Okay, so if I need to scan into the array, what do you think I need to do? Anytime I need to do anything with an array, what do I need to do? Anyone? Anyone? Come on, you know the answer. You all know the answer. Yeah? Scanf, and I need to loop. Yeah? So I need to loop through all the different elements. Okay. So let's do another little for loop, and I'm going to have an int I is equal to 0. I is less than my size of the array in this case, and I++ is how I'm going to control it. So I'm going to increase it by 1 each time. So what I want to be doing is I want to be scanning into the array. So I'm going to use the scanf function. Okay. I know that I'm scanning a %d. And let's actually do a little printf here, because otherwise it's going to not look as nice.
Is there a way to use a for loop in the similar way that you do in Python, where you can say like for I in a particular array or something like that?
Not really in C. No. If you're thinking, oh, Python's a better language, it's not a better language. Okay. How many hours did you watch on day blah? And I'm going to have I+1 because I don't want it to be on day 0. Okay, now scan D. What do you reckon is going to come after that %d? Where are we scanning into? What will I have as my variable that I added to? What do we reckon? Thank you, Sophia. Yeah. Yeah, so you have hours TV, square brackets, I. Okay, what about anything else I'm missing? Yeah? Ampersand, well done, okay. All right, so I'm scanning into my array at index I, really using kind of the same structure that I've used so far. Okay, great. So that will allow me to initialize my array. And now let's print it out now for fun, because, I don't know, that's what fun is these days for you once you're doing 1511, printing out arrays. And watching frozen computers. Okay, so let's do another little quick printout. So I'll go again. I is less than work week, and I++. And I'm just going to print out each element again. So I'm going to do %d. What's happening, Ben? Am I kicking you out of this lecture?
No.
Okay, let's do it. All right. Let's save it. Let's run it. And let's run it. Okay, how many hours did you watch on day 1? I watched 3. Day 2, 4, 5, 6, 7. Okay, and let's see what it's piled in. I did 3, 4, 5, 6, 7, and that's what it's scanned in. And so now that's what's sitting inside my array. So every time that I did the scanf, what happened is I placed it inside my array. So when I said, okay, I did 3, it scanned it into index 0 is the first one. Then the next one it went through, scanned it into index 1. And I did 4, scanned it into index 2, index 3, and index 4. So then when I printed them out, it was able to print them out as such as well. It went through the array, looped through it, and it was able to print out what is sitting inside my array. Okay, great. Now let's say I have Jake in here, but it should be Tom, shouldn't it? Okay, you'll cop it? Okay, Tom's copying it. All right, let's say that Tom is maybe trying to break the habit as well. Tom does not want to break his habit. I can do one of these loops as a while loop if you want, so you can see how it works together. Okay, so let's say my friend, let's call him Tom, although is keen to see what on earth the fuss is about, gets sucked into watching trashy TV also. Okay, so now I want to have a way to keep track of Tom's hours as well? What do you reckon I need? Can I just scan into the same array? No. Tom will need an array of his own. I feel like, Tom, you've fulfilled all your plans in life, your goals. You have an array of your own now. Okay, so let's give Tom another array. Okay, Tom, and it's going to have the same size. Okay, and so now we want to be able to keep track, and this is obviously a very contrived piece of code. Okay, it's not like you will ever do this. It's contrived so you can see how to scan into, compared to arrays. So it's not really a good problem. It's not really a problem. Well, maybe you don't have this problem in real life. Maybe you do. It depends. Okay, so let's scan into Tom's array as well. Okay. Should we do a separate loop here? Should we do a while loop for Tom? Yeah? Who's missing while loops? Oh, okay. All right. For you, Sophia, a while loop. Okay. So I'm going to do the same thing, but I'm going to do it in a while loop. Someone's just asked me to place an array in an array. You can indeed, and we're going to do that next week. You can place anything you want in an array. Woohoo! Yeah, it's going to be so exciting. Your whole array is going to be placing arrays into arrays. So it's going to be super fun. Okay. Let's do a while loop for Tom, okay? So I need a loop control variable in this case. Let's say int I is equal to 0, fantastic. And then I'm going to test it. So whilst I is less than, yeah.
Similar to how the 2D arrays are there stacks.
Here we go. Pointer arithmetic next. Okay, so inside here I'll have to increase my I as well. And let's scan into it now. So printf, how many hours did Tom watch on day blah? Okay, and then let's scan into it. So scanf, %d, and we're going to do ampersand, and then use the second array at index I as well. Okay, so what do we want to do next? We want to know the total number of hours that have been watched. Yeah? And this is also now, I'm just like repeating myself again. I'm scanning anyway. A lot of repeating code. Okay? I can make lots of things functions, yeah. So I want you to see that we're repeating a lot of code.
So can you return an array from function?
Oh, God, what a question. You're killing me today. Can you return an array from a function? No, you cannot. But do you need to? That is the other question. So I've said today that an array, when you pass an array, it's like passing a decaying pointer, which is making absolutely no sense to you until maybe next week. 2 weeks. Pointers in 2 weeks, not next week. So just hold on to it. It's coming. It's coming where it makes more sense. But it's all about passing around memory addresses. I can... So when I'm modifying the array in a function, it is potentially modifying it in the original array as well, potentially. It's wild. Just wait. But you can pass like if you wanted to, you could pass the memory address of one element of the array. Yeah. But not the whole thing. But it's returning a pointer because you would have to be return. Or if you're like returning an int, you might return an int, but it's got nothing to do with the array then. Yeah. And that's why pointers. Okay, sorry about that. Quick detour. Very good question. Can you return an array? No, you cannot. Simple answer to cut a long story short. Okay, so what were we doing? Let's add our arrays up, and then we can compare them. Okay, let's go through the array now, and this is getting very repetitive, I suppose. I'm going to go back to a for loop. Sorry, there's a comment in the chat that's just making my day. Okay, I'm going to go from int I is equal to 0 until I is the end of the array, basically, and I++ is my control. Okay, and what I'm going to do is I'm going to add up all of those arrays, basically. So, okay, something's going to be the matter here. This is not going to work. Okay, sum Sasha is going to be Sam Sasha plus hours TV at index I. And I can do Tom at the same time. So sum Tom is going to be the same as sum Tom plus hours TV Tom at index I. Okay, I need to, okay, and let's have an int sum here for me, and I'll initialize it to 0, and also 1 for Tom, and we'll initialize that to 0 as well. Okay, so what this will do is it will sum up all of those hours that we've just put into the arrays, and now we can compare them. Okay, so let's do one comparison so I can show you how to. I think the excitement started when someone wanted to return an array. Okay, here we go. So let's compare them. So to compare, we'll just use a simple if statement, and just really because I want you to see, and now it just says Jake's name everywhere, I'm sorry. Hey? Yes, I could find and replace, yeah, but where would be the fun in that? Okay, so if sum Sasha is greater than sum Tom, then I would like to print out that I watched more hours. Oh no, it was the other way around. Oh, God. Here we go. Okay. Now, what is happening with this printf statement? If you had that in your assignment, we would tell you that's not really working in terms of style, because that's going over the 80 character limit. Who knows how to break up a printf statement in code? Yeah?
You add a quote to the end of the line and then start the new line, add a new quote.
Yeah, perfect. Well done. So what you do is you basically do double quotes. So if I add a quote mark here, and then I will add a quote mark where I start the next one, and what happens is it just concatenates them together. Okay, so I could do something like that, and it will work fine. So I've got the first statement in quotation marks, double quotes, and then when I enter to the next line, I will have the next statement also in double quotation marks. Okay, now let's see how many things I put in here. Which one is which? So that's going to be me. That's going to be Tom. And that's it. Okay, so let's try and run it just for this first bit to see what it does, and then we can talk about it. Okay, madness. I've created madness because I used a lot of things, while loops, and oh yes, I've redeclared because I've used it. Yep. Okay, so what it's saying is because I've had a for loop here and I've used an int I in here, and then I've said int I is equal to 0, it's like I'm redeclaring it, so it's not going to like that at all.
But I thought the I is only for the for loop.
Sorry, this one here. So when I've got here in here, which line am I on? 41. Yeah, so it's because of this one here. Because I already have a variable called I.
That's why the style guide says that we want to initialize the variable used for the in the declaration of the.
Yeah. Okay, so let's run it. Oh, oh God, yes, sorry. We're back. Here we go. How many hours did you watch? 3, hey? 6. I'm going to go 6 again. And then Tom, 2 every day. Oh, daily dose, just keeping it consistent. And after all that, what has happened? It does not work. Where have we gone wrong? Let's have a look. Hey? There's too much happening. Where is it printing? Let's have a look. It's printing this one. And then it's just... I'm going to remove this print statement. This is what happens when the code becomes messy. Oh my God, not again. Okay, something is not working. And what is it? It's not really letting me go on. It's not really letting me think. What? No, I don't want you to answer it. No. Okay, someone's saying I only have one condition, which is not triggered. Okay. So what happens if I try and trigger the condition? That's good. So I'll reduce my watching and I'll increase Tom's. Very good. Well done. Okay. So because I only had one condition and it was that I had less TV than Tom, then it would do that. But obviously I wasn't triggering it, so it was just skipping over it and moving on down to kind of return 0 and exit out of the program. Okay. How is everyone feeling about scanning into arrays? Good? Everyone's happy? Good. There's a few goods. Anyone at the back? Thumbs up, thumbs down? Neutral. Everyone's Switzerland. Yep. Okay. Who wants to run through this line by line? Anyone? Yeah? A few people? Yeah. Okay. Let's run through it quickly. And then we will be... Okay, so let's do it. And let's say that I'm going to put in exactly what I've said before. So I'm going to have just 1s, and Tom's going to have all 2s. Okay. Shh. Okay, thank you. All right, line 23, we create an array for, I'm going to go like this for the array just because it's easier to do arrays like that. So I've created too many things for it. It should have 5 elements. So that's not here. Okay, that's my first one. It's called hours TV. Indexing 1, 2, 3, 4. So it's got 5 elements in it, and each one of them is an int. Okay. Then on line 24, I declare my next array. So I'm going to have one more array. Similarly, it's going to have 5 elements in it, so the same indexes, 0 to 4. But it's going to be called hours TV Tom. And everything is still an int. Then I'm going to create a variable sum Sasha, and it's going to be an int. And I'm going to declare it, assign 0 to it, so initialize it with the value 0. Then I'm going to have an int sum Tom, and that one is going to be initialized to 0 as well. Then I'm going to head into line 28, and I'm going to get an int I, and that int I is going to be set to 0 to start with. I'm going to check that that 0 is less than work week. Yes, it is, and work week is 5. Then I'm going to go in here and do something about it. So how many hours did you watch on the day? This placeholder is going to be replaced with I plus 1, which means it's going to be replaced with 0 plus 1, so 1 in here. And then it's going to scanf. So scanf and int, and it's going to put it into the address of hours TV at index I. My index is currently 0, so that means, let's say I'm going to go into this hours TV and I'm going to put a 1 here. And I could be using, the same for loop to scan both at the same time. I've just did one as a while loop to demonstrate that. So that it's not like this code is efficient and can't be improved. And after the lecture, you should go around and play with it and improve it and move things into one for loop and see what happens. Okay, so then I'm going to increase my I to 1, and I'm going to go and check it again. Is 1 less than 5? Yes, it is. So I'm going to go in here. Instead of this, it's now going to have 2. And in here, it's going to scan into index 1. So it's going to have a 1. And then it's going to go through again, increase it by 1 again, and check again. Is 2 less than 5? Yes, it is. Go through again and scan it into index 2. So now it's going to scan into index 2. I'm going to increase this by 1 with the I++. Check my condition again. Is 3 less than 5? Yes, it is. So I'm going to go in here again and now scan into index 3, which is this one here. I'm going to increase my I by 1 and check again. Is 4 less than 5? Yes, it is. So I'm going to go in here and scan into index 4. Excellent. And now I'm going to go increase that by 1. Check the condition. Is 5 less than 5? No, it's not. So that means I don't go in again. And I'll move down to here. So now I've got an int I that is equal to 0. So that's now going to be int I. It's equal to 0. Great. So now this one is gone because it was used inside the for loop. So it was available inside my for statement. Now I go into the while. So is 0 less than 5? Yes, it is. So I'll go in here and scan into the new array. So I'm going to scan into Tom. I'm going to move it up by 1 because I++ is just below this. Yes, it is. OK. So I++ is just below it. I'm going to increase it by 1, and then I'm going to check the condition again. So is 1 less than 5? Yes, it is. Go in here, scan into index 1. Excellent. Increase it by 1. Check the condition again. Is 2 less than 5? Yes, it is. Go in here again, scan into index 2. So scanning into index 2. Increase by 1. Yep. Check the condition again. So is 3 less than 5? Yes, it is. Go in here again, scan into index 3. So scan into index 3, increase I by 1, and check again the condition. Is 4 less than 5? Yes, it is. Go in again, scan into index 4, scanned, excellent, increase 5, and then check the condition again on line 35. Is 5 less than 5? No, it's not. So that means I exit out of the while loop. Okay. Now that I've exited out of the while loop, I will move on down to this next section over here. So when I move into this next section over here, I now have another for loop, okay? So this for loop now will go again. So I is equal to 0. So I've reset that back to 0. Is it less than 5? Yes, it is. I'm going to go in here and sum it up. So sum Sasha, so this variable here is going to be equal to whatever's on the right-hand side, and we'll do the right-hand side first before we assign it. So that's going to be 0 plus whatever is inside hours TV at index I. Index is currently 0. So then, how did that move up? Ah, there we go. So inside index 0 here is a 1. So what I'm going to do is that's now going to be 0 plus 1. So that's going to be reset to 1. And then this one here is going to be 0 plus whatever is at index 0 in the other array, which is 2. So it's going to be reset to 2. I'm going to go back and check, add 1 to my index, and check again, is it less than or more than? And then I'm going to go and perform these calculations over and over again. Okay? How's that? How's everyone feeling? I don't think I can go through another loop. I think I've done a lot of looping, a lot of for loops and a lot of while loops. So last poll, did Tom run the poll? Yep. What have we got on the poll? Okay, everyone's feeling a little bit confused, so don't worry. We're going to rehash on Monday in 38-degree heat, which might mean that it's going to be 45 in the theatre. So enjoy your weekend. I'll see you next week. Oh, and if you have any feedback, let me know. Struggling.